Good morning, everyone. Welcome to the second day of the SQL conference. I am not able to use the right pronunciation. My name is Russo. My session is about time intelligence in DAX and Power BI. So we are going to see how to correctly create calculations to perform calculations over time. And in particular, we will see a few important considerations about the right data model and the right data table that you should use in order to get the right numbers. I wrote several books about Power BI, DAX, and analysis services. For a living, I do consulting and I teach courses, and you will find many articles and also free content on the website sqlbi.com. So when we say time intelligence, we consider many different topics in a single name. So we consider calculations where we aggregate the dates, like the year-to-date, the quarter-to-date, and we also consider comparison between different periods of time. Give me the year-over-year calculation, or the comparison with the previous month or the previous quarter or something like that. Now, DAX is the key to obtain these calculations because DAX allows us to get some calculation done in the current filter. For example, you select 1 month or 1 quarter, but you can also change this filter in the calculation so that you can transfer the filter to another year, to another month, and so on. So you have the power of controlling the calculation using DAX. What about Power BI? Power BI has some built-in feature that should help you getting the dates, aggregated the right way, and getting the right calculation. However, you will see that I will suggest you to not use a few features, especially when your project will grow. And we will see this in a minute, because the first topic that I'm going to show you is how to manage dates with Power BI. And of course, I will spend most of my time using demos, and I have a few slides that I will use mainly as a recap of the concepts that we have seen. I forgot to run the tool that I use to highlight the code, because otherwise sometimes it is too small. Let me start this one. Here we go. So we have a relatively simple model here that I'm going to show you in the diagram view. In this model, we have 2 tables that contains facts. Facts are measures that consider numerical values for the sales and for the purchases. So basically, as you see, this model is relatively simple, but in reality, we have what we call 2 different fact tables, and 2 tables where we have aggregated data that we want to see compared together. For example, we want to see for a particular product what is the total amount of the sales for that product and the total amount of the purchases of that product, because we want to see the margin for the product. So far, so good. We have in this model 4 tables, and as you see, the sales table has a customer table attached to it, but the customer table doesn't have any connection with the purchases table. Makes sense, because I sell something to a customer, but I will buy something from a vendor, so possibly I may have another table. However, it's important that I have a shared table for the products. Why I have this? Because if I enter in Power BI, what I like to do is something like, for example, a matrix where I include here the product color, for example, and of course I had to increase the font because the Microsoft doesn't like we do presentation with the products, so we also have to change the default setting. Now that I have something that is visible, I can include a couple of measures that I have here: the sales amount and the purchases. So I have 2 different measures in the 2 tables. These measures simply aggregate the quantity multiplied by unit price of the sales of the purchases, and I see the total aggregated by product color. So far, so good, no problems. But of course, I may want to see some data aggregated by time, by date. So let me start removing for a moment the amount of purchases. So let's start with a very simple, sorry, let me restore the purchases, because I will show you the numbers, because I want you to see if the result is good or not. But in reality, remember that users like this. Users like charts. The problem is that when you see charts, if you have wrong numbers, it could be harder to understand what is going on. So especially when we create the data model, we want to use the numeric visualization, and then of course we will see some nice chart later. Now let's go back to my example. So for example, I just have sales amount and color and say, okay, I want to see the sales not by product but by date. Wait a minute, I have here in the sales table a single, actually two columns which are order date and delivery date. Order date is when I received the order for that that product, and the delivery date is when I ship the product. Well, I try to include the order date in my report, and as you see, I have one row for every date. Why I have one row for every date? Think about this. The content of the order date table, the content of the sales table, of the order date column of the sales table, is a column that has a date, which means that I aggregate by every day. But luckily, I have in Power BI a feature that allows me to do something that seems to help me. So if I go in the options of Power BI, and I go in this section, data load, you have this checkbox that, by the way, by default is enabled. So Marco, why you disabled it? Because I want to show you what this feature does, and why you should probably disable it from here in after. But wait a second. So if I include this and I click OK, then what happens? Let's start looking at the result. So if I remove order date now and I include order date again, before including order date, you see that now order date has a particular icon here. Oh, there is a hierarchy, and I see year, quarter, and month. So under the hood, a hidden table has been created, and this table contains year, quarter, month, and date, and there is a relationship with the sales table. Good, because this way I can aggregate data by year, by quarter, and I can drill down my report. So if I go here and I drill down, I can see the data by year, by quarter, by month. So far, so good. Oh, wait a minute. We wanted to compare sales and purchases, right? So let's do that. If I included the purchase amount here, Houston, we have a problem because the purchase amount is always the same. The date table that I have is only connected to the sales. The date table I have for order date is only connected to the sales table, but not with the purchases. So the filter is not transferred there. So if I was able to see the table, I will see here a date table connected to the sales table, like I have customer. But because this is connected here, this doesn't filter the purchases table. And we have another column, order date, in the purchases table, you see here, which has its own local date table. Now, but we have bidirectional filters. You don't have to use bidirectional filters in the model, but I show you another way, another reason, unless you know exactly what you're doing. If I enable the bidirectional filter here, what happens? I enable the transfer of the filter from sales to product to purchases. Actually, I have to do this here. This is the right place where I have to do this. But basically, what I'm saying is that if I filter sales, no matter how, I transfer the filter to the product and to the purchases. By doing this, you see some number. But what I'm seeing here, now, remember why I said I don't want to show you this. Because if I show you this, you may think that I'm doing the right thing, which is absolutely wrong. So for this reason, I mean, if you create a data model, and you create a report that doesn't work, you make people angry. But if you create a data model that works and produces wrong number, and someone will make some decision based on these numbers, and by the way, in this moment I see that the sales are way below the purchase amount, so I'm selling goods without any profit, which is very bad. But producing this could get you fired, because you are producing wrong data that could be used to make wrong decisions. So be very careful, okay? Now that I probably have your attention, let me go back to explain what is going on. The problem is the following. If I use auto date and time, which is enabled by default, and I enable the bidirectional filter that luckily is not enabled by default, but you can enable easily, it seems that you have different numbers, and if you don't have a knowledge of the number, you may assume that these are good numbers. But as soon as a business user look at the data here, looking at this chart, it probably realizes it's absolutely impossible that the cost of these goods, the cost of the sales, is double the value of the sales. Impossible. Okay, that's what happens. And you will see also that the number does not aggregate. So if you sum the quarter, you see different number than the total of the year. This is because of the many-to-many relationship that you are creating. So what's the problem? The problem is, if I filter Q1 2007, I want to apply the same filter, the very same filter to both sales and purchases. Look at what happened. Remember these numbers, 329, 679. If instead of using the order date from the sales table, I use the order date from the purchases table, now what happens is that, yes, I have here in Q1, 279. So you see a much smaller number in the purchases, but now the wrong number is in the sales. So I think that this is very confusing, especially for those users that don't have a good knowledge about data model, bidirectional filters. This is completely confusing. And the problem, in my opinion, is that because this is the default, it confuses people. The default is making the daytime active by default. So what I have to do, so let's solve the problem. What I have to do is, first, I want to disable this setting. I want to disable the fact that there is an automatic date-time table that is created under the hood for each single date column. Each date column creates a table. This is also expensive from a memory point of view, but this is a detail. What concerns me is not that I spend more memory, is that I have wrong numbers. And I disable this. Now, because I disable that, I immediately see a much more visible issue. If I include the order date, no matter what, I see days, and I realize that I need something to see data aggregated by year or by quarter or by month. What I need to do, I have to create a date table. A table that contains one row for every day, and that I will share across different tables in order to make my calculation correctly. Now, the problem is, unfortunately, we don't have a magic button that says, give me a date table. So we have to spend some time doing this. And of course, the first approach could be, OK, you can get a date table in any way. You can get a date table in Excel, in SQL Server, in M, in Power Query, or you can create it in DAX. I will show you an example in DAX, just because if you don't have the date table in any other way, you can still use DAX. But I'm not suggesting you that DAX is the best way to do that. It's just one of the tools that you have. What is important, you have to create this date table in some way. So my way to create the date table is the following. I can use the calculated table feature in Power BI that allows me to create a table from nothing. So this table is called date, and I can write calendar. Calendar is a magic function that gets to date. I want to get all the dates starting from 2007, 1st of January, and ends in 2009, 12/31. Okay, this is the limit of the bound. This is the definition of the boundaries of my date table. And if I click Enter, I have a single column that has one row for each date. And you say, Marco, we need the year. And I know, but we can do this better by saying, OK, I can add the columns to this table, and let's also use variables here, so we make the code more readable. If I var date list is equal to this, so let's start with this. So I start with this, and I say, okay, this is my list of dates, and I return another columns of the date list. There is an end that is missing. And for each day here, I want to add several columns. I will have the year, which is the year of the date. Then I have the month name that is equal to the format of, if I remember correctly, is this. And I have, for example, the month number, because the month name will be just a string, and we need also the number in order to sort the month the right way. So once I have this, you see that I have, wait a minute, the value in the format. I inverted the parameters. Here we go. We have January. Of course, if you have a German or an Italian or a French or any other language version, you will see this in your language. I just have to say, well, I want my month column sorted by the month number, and you do this way. And finally, there is another thing that I suggest you to do. Starting with the February 2018 version of Power BI, you also have, for the date table, this magic button, Mark as Date Table. Mark as Date Table is a very important function that I will explain you in a moment that is required for certain scenarios. Basically, we provide metadata to the engine saying, this table is a date table. And this particular column, when you click Mark as Date Table here, you have to specify one column of the table that has to be a date column, a column that contains dates, and has to be a primary key, has to be unique in the table. You need one row for each date. Sorry. If I do this, I simply informed the engine of this particular characteristic of the table. Sorry. Now that I have this, I can go back to the model. And of course, if I try to group my data, oh my gosh. Okay, I hope I will. If I try to if I try to show my report this way, I see that I'm not filtering anything. Why? I created a new table, but I didn't connect this table with the rest of the data model. So this is the situation. I have the date table, I have sales purchases, and there is no connection, no relationship. But what I can do at this point, I can connect the order date column of the sales table to the date to the date column of the date table here, and I can do the same between the purchases table and the date table. Of course, as you see, this relationship has been created as an inactive one, and the reason is that I kept these relationships are bidirectional. This is a bad practice, as I said, because it created an ambiguous reference, an ambiguous set of relationships. So I disabled the bidirectional filter, and let me create this relationship again. You will see that if I connect order data to date here, I create a regular relationship. So this relationship is an active one, and it transfers the filter the right way between data and purchases. And now, magically, just because I created the relationships, my report now is correct. And if I drill down this report by month, for example, here, and I include this here, and I drill down, you will see that month by month, I had the right numbers. Okay, I could create the quarter at this point, but I will show you in a minute that I don't want to lose my time just writing date tables. So basically, this way, my line chart will be correct. And as you see, the purchase amount, luckily, is usually smaller than the sales amount. There is a margin. Okay, the green line is the sales amount, the black line is the purchase amount, the black line should be below the green line. So also the chart demonstrates that I have good numbers so far. Okay? Now, let me go back to the slides just to recap what we have seen. So we said that this setting, the auto date time setting, is enabled by default. It builds a date table with a date hierarchy, but basically you have a few limitations. First of all, you have only year, quarter, and month. What about the weeks? What if you want to display the month with a different convention, 3 letters instead of the entire name? So yes, it's automatic, but the biggest issue is that it creates one table for every date column in the model. This is not necessarily a best practice. If you have a model that has only one table, it's fine, but as soon as you have multiple tables and multiple dates with different granularities, it's absolutely bad. What you want to do is creating a shared date table, and the shared date table has relationships with the other tables in the model. So this is the list of the issues that we listed for the auto date time feature, and so we created a date table by ourselves by using DAX. This date table has can be written in any way. We use DAX just because it's very, very easy to use in this demo. And remember, one important property of your date table is that it has to contain all the days in 1 year. Now, the year could start in the 1st of July if you have a fiscal year that ends in the 13th of June, but you don't have to skip Saturday and Sundays just because you say, oh, there are no sales. It is a best practice to include all the days, even if you have no data, because otherwise the time intelligence functions that you have in DAX could not work as expected, and I will show this in a moment. So for making sure that the time intelligence works, we need a complete table, and we have a set of functions. We also have a function called calendar auto. We use calendar. Calendar expects 2 arguments, the first and the last day, but calendar auto expects no parameters at all. You just specify what is the first month of the year, and if you specify 1, of course, you get from January, but if you specify 7, you say, okay, I want to get a year that starts in July and ends in June, because you have the fiscal year defined this way. Now, calendar auto scans all the tables in your data model, all the date columns, and if it finds a date column, it evaluates the minimum and the maximum values you have there, and it includes a range of years that span for all the dates that you may have in your model, which could be a problem if you have a customer table with a birth date, because you might have sales only for the last 3 years, but you have 100 years for the birthdays of your customers. So be careful using calendar auto. Otherwise, you can just use calendar. And by using calendar, you might make it more dynamic. For example, we might use min and max to get the minimum and the maximum values of the dates from some table. But the best practice is to use, for example, the year of the minimum and the year of the maximum. So there are different examples. However, I don't want to spend my time every time I start a new project. I don't want to spend my time writing this boring DAX code, always the same. And then, remember, it was not enough creating the date table. I also had to go here and say, OK, because I have the month name, I want to sort the month name by the month number. It could be a good idea, because the month number is just used internally. I want to hide this month number. And then it could be also another good idea in the report to say, OK, I want to create a hierarchy, so that if I create a hierarchy defined this way, I will have year, month, and date in this sequence. So if I include the date hierarchy, I immediately have year, month, and date, or year, quarter, and month in a particular order. This is time-consuming. Every time I do this, I spend my time, and I could do something better. So for this reason, I spent some time to write a single date table that I can reuse easily. This project is an open source project, so you can go to this web page, you search a DAX date template, this is the version 1, but in reality, behind the cover, there is an open source project on GitHub, and so you can contribute and you can do many things. What is this project about? The idea is the following. I downloaded this file, which is a file that is a PBIT file, not a PBIX. It's a template. A template is a model that has no data. And if you open a PBIT file, you open a new file that is completely empty, and in this case has only one table, date. So when you create your new project, you can start from this model, and you obtain this. 1 second. Here we go. You obtain exactly this. Let me show you. This is the definition of the date table. It's 1,100 lines of DAX code. But you don't need to review that, because at the very beginning of this code, we have a set of variables that we can use to say, well, I want to get the data from 2007, for example, until what I use here by default. I set the reference is today, and I want to get all the data until the year that contains today. But you may change this, and you may say, no, the today reference is the maximum value of, for example, the sales order date, and here you can use the year from another year. For example, I could say, OK, I want to include here 2009. Okay, this way I create 3 years. I click Enter, and I automatically get my date table. But as you see, this date table has a large number of columns. And a large number, most of the columns are hidden because they're used just for internal calculations. What I show to the user are a limited number of columns here and hierarchies. And we also have a number of calendars. We have the fiscal calendar, the regular calendar, and the fiscal calendar based on weeks. You may say, Marco, wait a minute, we don't need all these calendars all the time. I know. But it's much easier to remove something rather to add something to a table. So here, if I go back to my date table here, I can use this editor, which of course is a good editor, but I have a better one. So I copy this code into DAX Studio here, which allows me to extend this code this way. I can also zoom the font. And here we have, as I said, this is very, very long. We also included the management of the holidays, country by country, and so on. But here at the very end of the code, we have syntax here based on select columns. Select columns is like a select statement in SQL, and we have a list of the columns that we want to use. So if I remove, so let's say that I just needed the calendar, the solar calendar. I don't need the fiscal calendar. I don't need the fiscal calendar by week. I just delete these columns, OK? I copy and paste the code here, and I click Enter. Here we go, done. Now my date table only has the remaining column, and doing this, I didn't lose the definition of the hierarchy, of the sort by month, sort by column, setting, all this stuff. I measure that I save 10, 15, 20 minutes for every new model I create this way, because I don't have to spend my time there. So this is a good way, a good approach to obtain your date table. Oh, but of course, you can also just get some idea from this huge calculation to create your own. It's clear that I would like a button, create my date table in Power BI. I would prefer this, but at the moment, this is what we have. As I said, it's important that we mark the table as a date table. We set the sorting option, sort by column, and wait a minute. What if we have multiple dates? If you remember my model, and so I go back to my time intelligence model, we created the relationship between date and order date. But in reality, if I look at the model, there is also a delivery date. A delivery date for the purchases, a delivery date for the sales. So I can simply create the other relationships, but of course, only one relationship between two tables can be active. The other relationships will be non-active. And this means that if I want to show, so my measure now, sales amount, is the sales amount or the purchase amount based on the order date. I can simply create a new measure here, new measure, And in this new measure, I can say, OK, the delivered sales is equal to calculate the sales amount. So I want to compute whatever I have in sales amount is good. But for this calculation, I want to make the other relationship based on the delivery date active. When you have an inactive relationship and you enable this relationship using use relationship, the active relationship becomes non-active. This becomes the active one. And the calculation that you have in the first argument of the calculate function will be executed considering the delivery date as the active relationship. This way, if I do enter and I set this this way, so if I go back to my report using just the matrix, and I included the delivered sales here, you will see that I have a different number, which makes sense. In January, I received order for 101,000, but I delivered only for 87,000, and so on. You may say, Marco, but this way, we have to create one measure for every date. Yes, because you have to think about the alternative. And you don't have to think about the alternative from the point of view of who is creating the model, but from the point of view of who will use the model. And let me show what is the alternative. The alternative is, I can close this. The alternative is, I can get this code, and I create a new table, delivery date, which is equal to this. Now, because if I create the code this way, this way. Okay, so date list. Okay, sorry, I made some mistake. Okay, so if I click this button, I created another table that is identical to the previous one, identical, but has a different name. Because it has a different name, I can go back to my model, and I can connect the delivery date to the date column of the delivery date table, and the same here. So if you do this, now you have that the sales amount measure of the sales table and the purchase amount measure of the purchases table can be used using two different dates. What does it mean? Oh, simple. If I create a new report here, and I create a matrix here, and I include here, let's say I want to include the delivery date here, and I include the purchase, the sales amount here, and I just have to increase the font. As I said, there is no way to make this smarter. Okay, this is the sales amount by delivery year. And what if I use the order year? So if I go in the order date, or better, in the date table, and I use my year column here, I can use this here, not in the measure, but in the columns, and I have this, which makes sense. In 2007, I received this amount of orders, but I delivered most of the orders in 2007. This is exactly the amount of the orders received in 2007 and delivered in 2008. Interesting information. But the problem is that most of the time, not always, but most of the time, what users want to do is this. Compare sales and delivered by date, having a single date. Not this. Yes, from a technical point of view, oh, this is more flexible, but it's not what most of the people do usually. Moreover, there is another problem. If I look at the report, it's very hard to understand what is the delivery date, delivery year, and what is the order year. Yes, of course, I can modify the content of the table. So, for example, for the delivery date, I might write here, oh, instead of writing year date, I write delivery year as a prefix of this. So now this will be something easier to understand, okay? Because I see a difference between the two columns. But as I said, if you do this, you cannot mix the two. Imagine you have only the sales amount measure, and you want to create a report like this one. comparing delivered sales and sales amount row by row. It's impossible. You need to share a date table. So in my experience, a shared date table is what you need 95% of the time to make the life of the user simpler, the life of the user that creates reports, which could be yourself. 5% of the times you need this. But in these 5% of the times, you have to identify this table using different names, different content. You have to make the content understandable. And increase the flexibility, in reality, makes the report harder to build. So only when you have the real need to create this sort of matrix where you intersect the two different dates, you really need two tables, two date tables. OK? So what about calculation over time? So now we have a date table, and we want to create something like this. Let me show you the final result we want to obtain. So if I go, give me 1 second. If I go here, you see that I have a calculation like, how can I remove this? No way. OK. Here we go. Year to date. Look at this number. You see this column? This column has a number that increases quarter by quarter. Sorry, I have to sort this the right way. July, August. OK, now it is the right thing. So if you look at the number here, you have 473, 506, 473. If I go here, you see that the number increases every quarter. And when I reach the end of the year, it restarts from the beginning. So it's the year to date. Give me the aggregated value from the start of the year. How can I obtain such a number? How can I modify my code? So let me go back to my original model. So from here and after, I want to use this model. Let me remove the purchase amount and the delivered sales from this example. So I have only one measure here, and I want to create my year-to-date. So in February, I want to see the sum of January and February. In March, the sum of January, February, March, and so on. Now, if you think about what you can do in DAX, this is a calculation you can do in DAX without any further help from existing functions. So if I create my measure here, new measure, sales YTD, okay, what I can do is I want to calculate the same measure that I already have, sales amount, and I want to apply some filter so that my calculation will be the right one. What could be the filter that I can use? Well, the filter that I can use, let's start with a simple filter. I want to filter all the date, or all the date. Let me write it simpler. I want to say that the date column has to be. Let's start creating a simple calculation. Let's start to create the year-to-date from the 1st of January to the 31st of March. How do you write this? Well, this has to be greater than or equal to the date 2007-11, and it has to be less than or equal to of date 2007-331. Now, the problem is that if I write the filter this way, okay, I'm missing something. And I include this code here, and I include my calculation here. What you see is that this number is always the same, no matter what is the selection. Because I write a fixed filter that overrides the existing filter in my report. What I can do, I can make this filter dynamic using the current selection in my filter context. And how can I do this? Well, for example, I could use, again, the variable saying, let me see, what is the last day selected? Oh, it's very simple. It's the maximum value of date to date. This number corresponds to the last day in the current selection. So for January, it is the 31st of January. For March, it will be the 31st of March of the same year. Once I have this number, I can use the last day selected to replace this fixed value here. And if I do this, and I look at the number, you see that I already have my right calculation in March is correct, but you see that all the other months are correct too. However, if I scroll down, I have a problem. In January 2008, I'm still increasing values. Of course, because my filters from the 1st of January 2007. Here, the dynamic part that I have to change is the year. And the year should be the year of the last day selected. That's it. Done. Now this starts from January, and it performs the calculation. So basically, if I know how to manipulate filters in DAX, I don't really need a ready-to-use function that does the job for me. Because you know what? This function exists. But this function does exactly the same thing that I'm doing. Please remember that when you write this code, in reality, you're writing this. Filter all date, comma, and then you have the expression. Which means that basically, the result of the predicate that I'm writing in calculate, in reality, is a table that has one column, the date that I want to filter, and as many rows as the days that I want to include in the filter. Internally, this is what happens when you write a predicate in calculate. Now, instead of you writing this code in an explicit way, you have a function in DAX that is called dates.ytd that does this job for you. And if I write the code this way, now I can also remove my variable, because it is included within dates.ytd, and I click Enter, I have exactly the same number. Because internally, dates.ytd is a table function that provides exactly the same result. It reads the filter context, it evaluates what is the range of dates, and does the calculation for me. Done. I introduced you the first time intelligence function in DAX, dates.ytd. As you can imagine, there are different functions that differ only for the syntax. You have dates month to date with M, quarter to date with a Q. We don't have functions for the weeks, because for the weeks, the DAX doesn't provide you any help. The problem will be clear in a moment when I will explain how the comparison works. Because now we are aggregating data. We are aggregating months, quarter, years, right? And again, Marco, but do we have to do this for every single measure where we want year to date? Unfortunately, yes. We don't have a way today to apply a transformation like, oh, please, give me the year to date of an existing measure without having to write any DAX code today. Maybe in the future, I don't know how far, we would have such a feature that already existed. For those of you that know analysis services multidimensional, we have techniques that are called date tool, where we create a dimension that contains the transformation we want to apply to an existing measure, and we don't have to write any code. In DAX, we have to write this code. Now, you can use a wizard, you can use a template, but basically, you have to do this. OK? So there are many functions that I will not describe, because what is important is that you understand the concept of this. Okay? You understand how this works. But let me think for a moment for those. How many of you know the filter context, how the filter context propagates in DAX? Not many. OK. So let me give you a hint here. If you remember how I wrote my code, I wrote a filter over a column date. A column date, right? Wait a minute. My report has a filter over year and over month. And I didn't clear this filter. So in reality, if I knew filter context, the theory of the filter context, I should expect that this calculation wouldn't work. And actually, the calculation doesn't work in another scenario. Let me show you with this. If I remember correctly, this model is similar to the previous one. So we have, in this case, we have sales and inventory. Let me fix this. We have the sales table and the inventory table, but you see that the sales table is connected to the date table, the sales is also connected to the products table. So far, so good. But the connection between date and sales is made using a column called date key. What is the content of date key? If I double-click the relationship, you see that I have in the date table a column that contains a date. It's called date. Date key is an integer. It's not a date column. It's an integer. Many existing databases, for a number of technical reasons that I don't want to explain now, store the date in an integer format, like year, month, and day in an integer. 2005-0102 is a number. Now, it's perfectly legal using this technique, this approach, and it's perfectly legal to create a report. So if I go here, and I create my report here, and I include here my, let me see, date, year, here, come on. Date year here, then we increase the font. When they will do a different default here, but I increase the font and I include my sales amount. I have a sales, sales measure, and I have a number. So far, so good. Now let me check why I have the fiscal year. Well, yes, because this is with a fiscal. So let me see. That's fine. That's fine. I can use this. So I can include the month name here, and I can drill down with a month. So if I do this with a matrix, and I include the month, and I increase this, and I drill down, I had a value by the month. So far, so good. Now I can try to write my dates YTD. Let me check before I move forward if I have this markers date table. Okay, let me remove this one. Okay. Oh, I cannot do this. Let me remove the markers date table, otherwise I have to start from scratch. Come on. It doesn't answer anymore. It's not helping me this way. I'm clicking on the button and nothing happens. I don't like this. Come on. No way. You know the demo effect. Okay, no problem. So let me close the file, and I open the file again. I think I can do this. Basically, what I want to show you is that in this condition, when I will use the dates year to date, if I don't have the markers date table set, the calculation doesn't work. And the calculation doesn't work because when I apply the filter over the date, there is some assumption made by the engine about the correctness of the calculation and the requirement of removing the filter from other columns of the date table. So let me first remove the date and markers date table. Yes, working on it. Okay, good. Good. Okay, it should work. It should work the demo, which means that my calculation will not work. So I have to include the year, I have to include the month, I have to include this this way. I drill down and I increase the font, and then I will make it visible. Okay? Oops. The grid, the font, and then I included the sales. And we are working good. Okay, now I create my year to date. So I create a new measure here. This measure is my YTD, which is equal to calculate of sales for dates YTD. So I use the same function that we've seen before, date to date. Okay, this way. I do this. I include my year-to-date calculation in the report here. And as you see, as you see in a moment, I just want to fix the decimal numbers. Come on. Okay. The numbers is identical. So the year-to-date is not working. Okay, it's not working. Now, if I change the relationship, remember, now my relationship is based on the integer value, okay? If I change the relationship, and instead of using the order date key, I would use the date, it would work. We have seen this in the previous demo. But in this case, my sales table doesn't have a date. So how can I fix this? Simply by doing this. Well, I have one solution in DAX, which is I add here all date. If I do this, my calculation works. Because I'm saying I want to apply a filter over the integer column, and I want to remove the filter from all the other columns, the year, the month, no matter what. Now my year-to-date is working. You see that the number in August and the other months is working, right? It's correct. So how can I obtain this behavior automatically? Instead of using this all date in every single measure, which could be boring, I simply go to my definition of the date table here. I go in the markers date table, and I set that the date column is the date column of the date table. At this point, if I apply any filter on that column, the filter is automatically removed from all the other columns of the same table. And this is the reason why my calculation is working here. Because now the filter applied over the date column in the date table automatically removes the filter from the other columns of the same table. For this reason, using markers date table is a suggested behavior. And this is the reason why here, I will show in a minute, that we have seen different aggregation calculation. We have seen that we can write our calculation as a filter in an explicit way. It is possible. And we have seen that I can make it dynamic, and I can use dates YTD, which does the job for me. Okay, so far so good. We also have other variation like total YTD that allows you to not write calculate and use just a single function instead, but it is just a syntax sugar. It's just a way to simplify the code if you want. But important, what happens if I have an integer key, which is a very common situation if you extract data from some data mart, data warehouse that store data dates this way. So with the February 2018, we have markers date table. In the past, we didn't have this, so we had to do some other workaround. You will find articles about that also on SQLBI.com, but luckily, with the current version, we no longer need this. Remember, you have to specify the right date column, which is the date column from the date table. If you specify the date column from the sales table, it will simply not work because you apply the filter on the wrong column. If you have a fiscal year, I didn't show that, but in the case of a fiscal year starting in July, we have a second or third argument for total YTD, which is the last day of the year that you want to include. So basically, the calculation of the beginning of the year starts from the next day of the next month. What about the comparison over time? What if we want to compare one month with the previous month? Now, this time, instead of showing you how to do the calculation starting from scratch, I do the opposite. I start from the existing calculation in DAX, which is way simpler, and I will explain why in a couple of minutes. So let me go back to the simpler model that I created, which is the time intelligence, this one. So here I just have my year-to-date calculation here. Let's do this so we have more space for the formula. We have I have my year-to-date calculation. I want to show month by month the value of the previous month, because then I want to create a month-over-month and a month-over-month percentage, right? So it's relatively simple. I can have this way. I can do this calculation this way. I create a new measure. Sales previous month is equal to calculate. Once again, the pattern is very, very easy. So you basically start the calculation with calculate, and you apply a filter that says, I want to transfer the filter to these dates. That's the idea. And we have to find a function that gets the current selection of days and transfer this selection to another period. So you can write this using dateAdd, which is a very generic function that says, OK, I want to get the current selection of dates, and I want to go back -1 month. You can specify here, instead of month, you have day, month, quarter, year. You don't have weeks. As I said, weeks are not supported. I will show you a workaround in a moment. So I go here and I specify month, and I click Enter. OK? Now I show this code here. So let me fix this. And I show the code here, says previous month. Here we go. You see that February has January, and so on. Easy. Now let me explain you why I didn't write this code by hand. Think for a moment how many days we have in February. In 2007, 28. How many days we have in January? 31. It's not so easy to write a filter that gets 28 days as an input and provides as an output 31 days. Is it not enough to get, oh, I will subtract 1 from the month? It's not enough. Then you have, oh, but in January, you have to go back to December and subtract the year. So if you think about the logic behind, it's not easy. And this calculation has a more sophisticated logic that says, if I selected all the days in 1 month, then I provide you all the days in the previous month. So this is the case where this works, because I have all the days selected. You see that the number is the same. But if you selected only a few days, then only those days will be selected in the previous month. How can I obtain this in an easy way? Just to make sure that, just to see if I'm telling the truth, right? In the date table here, I can create another column called, let me go to the date table, and I create a column called day of week. Okay, equal format of date, and I create another column, day of week number equal to day, week, day of day, date. And then I sorted the day, so this is invisible, and this is sorted by day of week number. Remember, if you import the date template, already done, okay? Then I go here and I use this, and I create a slicer here, and I include in the slicer the day of the week. Here we go. Okay, look at, now the numbers are identical. Now let me choose only the Tuesday. Here we go. Doesn't work. You see that the value of February is 27,000, the value of January 41,000, the value of the previous month for January is 7,000, which doesn't make sense, right? Because if, think about this, I included all the Tuesdays, so no matter what, I should see the same number. But of course, if you select only a few days in February, and you go back for the same days 1 month, you will not see the same numbers. Moreover, you have a conflict between the filter. Oh, you are filtering the day of the week, which is different if you go back for the same relative day in the week in the previous month. This is just to show you that depending on what you're doing, the time intelligence function could serve you well or not. Just to give you an overview of this function, because of course there are many functions. Same period last year is the same as dateAdd, date minus 1 year. So give me the same value in the previous year. You can combine these functions. So for example, what if you want to get the year-to-date of the previous year? You can combine these functions. The first argument, when you specify date, could be the result of another table function that gets a transformation over dates using another logic. So you can compose the logic of shift in time and aggregation over time, if you want. DateAdd is the generic function that you can use. And as I said, DateAdd simply gets the current selection and transfers the selection 1 month back. What if you want to get the entire period, the entire month? You can use parallel period. So instead of DateAdd, parallel period, always get the entire year or month or day or quarter. So using parallel period, you can create some calculation that ignores my selection. So for example, if I do the same if I transform my sales previous month here using, instead of date add, parallel period, okay, the calculation seems similar, but if I do this, now you see that the value of the previous month is 101,000. That, if you remember, was the total of January, no matter what is the selection of the days. Again, it depends on what you want to do. But if you want to get the total of the month, no matter what is the selection of days or other stuff, this is the way to go. Instead of using parallel period, if you have -1 month, there is a function called previous month, just syntax sugar. You can do this. Same result, same result. So previous month, previous day, previous year are just syntax sugar for date add -1 and the corresponding offset. Dates in period is what you can use to get what is called a sort of last 12 months, last year. For example, I'm in March 2018, and I want to get the value from the 1st of April 2017 to the 31st of March 2018. You can obtain this using dates in period. This is very, very good to get a sort of rolling average or rolling sum that always consider the same period, removing seasonality from the calculation. What if you have weeks? What if you have something that is non-standard, not a standard month as we want? Well, the idea is that the time intelligence functions in DAX makes an assumption. You're using a regular calendar, and you are not using weeks. If you are not satisfying these conditions, you have to avoid using the standard time intelligence functions, and you have to write your own calculations. For example, think about this. It's not hard to do. If you want to create a running total that always computes the total since the beginning of the history, you just have to write your own filter, like I did before, where I forgot to make my beginning of the period a dynamic one. And what if I want to implement the previous month in a custom calendar? Of course, this calculation is much more complex, but don't worry, it is written in some article on the web. And I want to just show you the idea behind. As I said, the date table that I shown you from the time intelligence, the date table that I shown you from the template is something that has a more complex definition of the date table. Here we see an intermediate version. And this intermediate version simply has, different columns for the quarter, for the month, but you also see numbers like the year quarter number is the sequential number of the quarter since the beginning of the history. And the same for the month. These are hidden columns that have the only purpose to make it easier to write my custom calculation. And by leveraging these columns, for example, my month over month calculation, so my previous month calculation, let me see if I find the calculation here, aggregation. I don't remember the name of the measure that I used. So give me 1 second. It is previous month sales, PM sales, so PM sales. Here we go. This is an example where I applied a filter. If you look at the code, it's a little bit complex, I understand this, but if you look at how the code works at the end, basically the code iterates a year-month number, so basically for each month, it applies the logic that calculates the sales measure, so the original measure, applying a filter over the year-month number. So if you look at the code, the big difference is that instead of applying the filter over the day, the date, I apply the filter over a column that has one unique value for each month in each year. This could be important in 2 cases. First, you have a non-standard calendar, which is one case. The second is you are using direct query. If you're using direct query, using this approach, you simplify the SQL code transferred to the, not you simplify, but you make the code transfer to SQL Server, a code that will require a lower amount of data to be transferred from SQL to analysis services or to Power BI. Because the default behavior is to always filter by day, even if your report shows data by year, which means that you are multiplying by 365 the amount of data that you are transferring from SQL Server to your Power BI or analysis services engine. So we have seen that the calculation is based on the filter context. It's important to understand how the filter context works. We have many predefined functions in DAX that helps you to write the time intelligence calculation, but you can author your own function. So you can create your own calculation, even a custom one that manage a non-standard calendar. So learning DAX is the key. You will find many, many examples in our website, SQL BI, or also in daxpatterns.com. If you have any doubt, send me an email, marco@sqlbi.com, and I will provide you links and suggestions. Thank you very, very much for your attention. I know that we are a little bit over time. If you have any question, I will be available here. Thank you.